Hi, my name is Duncan Carson and I'm going to take you through HTML5 application development fundamentals. In the first lesson we're going to be talking about the application lifecycle, which consists of understanding the platform fundamentals, managing the state of an application, debugging and testing an HTML5 based touch enabled application, and how to publish an application to a store. Let's have a quick look at the agenda. First off, we're going to be looking at the steps of app building. Secondly, we'll be talking about the runtime environment. Then we'll be looking at managing app data. The fourth section is going to be about debugging and testing an app. Then we'll look at validating an app. Then we'll look at publishing an app to a store. And finally, we'll look at packaging apps. Before we get into the steps of what you need to do to build an app, let's just have a look at the HTML5 family. So a very quick summary here. So HTML5 then is a markup language, as well as being the term used to describe the whole family. It is also sort of a markup language in itself, so a set of specifications relating to that markup language. Okay, so it's not a programming language. So what happens is that the HTML uses markup tags such as body, h1 and p, img, many other things to describe parts of a web page. Okay, the second member of that family is CSS, or cascading style sheets. Now that defines styles for HTML, which are usually stored in a separate file or files, so that you can easily change fonts, font sizes, and many other attributes from that CSS file. The third sort of main component or member of that family is JavaScript. So JavaScript is a scripting language, so a programming language that uses scripts and requires no compiler. Okay, so JavaScript adds interactivity and sort of level of dynamism to web pages. Okay, regarding the HTML5 hypertext markup language itself, quote here from Mozilla: HTML5 is the latest evolution of the standard that defines HTML. The term represents two different concepts. It is a new version of the language HTML with new elements, attributes and behaviors, and a larger set of technologies that allows the building of more diverse and powerful websites and applications. So this set is sometimes called HTML5 and Friends, and often just shortened to just HTML5. I think it's worth noting as well, a really good place, many of you probably are aware of it already, to start to find out about HTML5, including CSS and JavaScript, is W3 Schools. Okay, so if you go to W3 Schools and look up HTML5, fantastic resources there, and to be honest, I think it's hard to find anything much better than that. It's all free to use, so strongly encourage you to check out W3 Schools. I just want to alert you to that particular link on HTML5 on W3 Schools. Really worth navigating to that. Strongly encourage you to look at that. It kind of brings some of the things that are in the ebook together, because hopefully you will have received this by now. If you haven't, then you can get it on campus. But there's a few things in there, a few sort of HTML5 kind of technologies, specifically APIs, which are mentioned on that page, and then you can sort of look them up as well a bit on there. So stuff like geolocation, drag and drop, local storage, application cache, web workers, and SSE. You can find out a bit more about those on there. They're all discussed, or most of those are discussed to some extent in the ebook. Okay, so those technologies are really worth looking at. Also worth having a look at the timeline and versions, the different versions of HTML5 that have come about, or just HTML that have been around. In 2012, there was the WG HTML5 living standard, which was a standard that was included stuff which once placed into the standard would not then be removed. From sort of after 2012, W3C took over and came up with the HTML5 recommendation in 2014. In 2017 there was the HTML5.1 that came out in October of that year, and closely followed up in December of 2017 by HTML5.2. Okay, so just out of interest, worth having a look at that timeline, and the WG group as well. There's a link there to that, so it's good to have a look at the responsibilities that they have relating to HTML5 and other technologies as well. Okay, but the main organisation with responsibility for HTML5 now is really sort of W3C. Okay, just a couple of things to mention regarding the fundamentals about platforms. HTML5 is platform independent. Okay, so that means it's a technology which can run on a huge range of browsers, devices, and different operating systems. Okay, whether it's Android, sort of Mac OS, Windows, different types of smartphones, tablets, PCs, whatever. HTML5 will work on it. Okay. The main standards body, as we said, is W3C, so the World Wide Web Consortium. Okay, so they're responsible for developing specifications for HTML5. And I'm sort of mentioning this because it's from the book, really. They sort of mention Windows 8 and the fact that Windows 8 uses what's known as a Metro style interface. Okay, so that was intended to be kind of an app-friendly type interface, which made use of a full screen, sort of lateral scrolling as well as up and down, and sort of large hubs or buttons and that sort of thing. Okay, let's have a look at the steps of app building. Okay, if you follow the kind of a yellow line around those 9 rectangles, that takes you through the process of building an app, a very sort of high level view. Okay, so you start off with planning your project, just organising things and thinking about what's going to be involved in it. The second step would be to design a user interface. Thirdly, you would update the manifest. The manifest is basically just a file which states everything that's included in the app. Fourth, you would start writing the code itself, and then fifthly, you would actually start building the app, sort of organising and putting together the different components of it. Then you would start testing and debugging the app. Perhaps get other people involved with that as well, to provide a bit more objectivity. Seventh step would be to package the app, i.e. to create a container holding all the required files. Then you would validate the app, which would involve passing it through some sort of validation program to ensure that nothing's missing. And finally, you would deploy the app, which basically means uploading it to a marketplace such as the Windows Store. This is just a manifest file example. So it's a fictitious example, and it's an XML file, which shows all the sorts of things that you would typically find in a manifest file for an app, such as the package, the properties, prerequisites, the resources, and some information about the application itself, and perhaps the sort of logos that might accompany the app. Let's have a look at the runtime environment. Okay, so when you launch an app, it runs inside a runtime environment, or RTE. An RTE is where the users are running the app, and it's also where the developers can test it. So in Windows, this environment is called the Windows Runtime, or Windows RT. That runtime environment is provided by the .NET framework. And on your screen there, you can see an image of WinRT, the Windows runtime environment. We can see that it works with C, C#, C++, Visual Basic, XAML, which is the kind of Microsoft version of XML, as well as HTML, CSS, and JavaScript. Okay, and you can see some of the WinRT APIs that have access to sort of communications and data, graphics and media devices, and printing and so on a device. Okay, so Windows Runtime WinRT, so it provides developers with access to a user's device, okay, whether it be to the hardware on there or whether it be to the operating system itself. Okay, so it does that through WinRT and the Windows library for JavaScript APIs. Okay, an API, as you probably know, is just an application programming interface, which is a set of guidelines that allows one program to communicate with another. Let's have a look at the app container. Okay, so when a web app executes, it does so in a contained environment. Okay, so every app runs in its own container. So you have an app container. Now that's a separate memory space. You don't want memory addresses relating to one app contaminating the sort of area of memory allocated to another app. Okay, because it could lead to sort of corruption of the operating system. So the purpose then of an app container is to prevent apps from corrupting the operating system, and each container has its own memory space, as you can see in that diagram there. WWA host.exe is a process which allows apps to run inside Internet Explorer. So if you were running this and you opened Task Manager, you would be able to identify that process within Task Manager. Let's go over a few features of the .NET framework. So this framework provides a secure environment for web apps to run in. It provides a library of shared code that developers use for common functions. It uses identity permissions to protect assemblies, and assembly is a compiled code library. The permissions are usually based on the source of the assembly, so that would either be from a local machine or from the internet. And the framework uses security transparency to separate different kinds of code while running. Again, this transparency prevents app code from running with infrastructure code, and thereby causing some sort of corruption. And permission sets define what application code has access to and what it has the ability to do. It also includes class libraries which implement functions such as file reading and writing, graphics rendering, database interaction, and XML document implementation. Let's have a look at a couple of things relating to accessing a web page. Okay, so when you enter a URL into the address bar of a browser, the browser sends an HTTP request to a web server for a web page. So HTTP is short for Hypertext Transport Protocol. HTTP is a stateless protocol, which means that it doesn't retain data from session to session. Okay, so any data relating to earlier requests is unavailable and not stored. Okay, so the opposite of a stateless protocol would be a stateful protocol. A stateful protocol would access data from earlier requests also, which have been stored. So when we close a web browser, when we've been using HTTP, after the application has been used, the data is not automatically saved. Okay, so basically, if you if you're just using HTTP and you close the browser, none of that data is going to be remembered. Okay, I know that there's ways around that, which is one of the things that's going to be discussed later on in the course. But just remember, HTTP itself is a stateless protocol. Let's look at how states are managed. So when a user requests access to an application or uses a web browser, a state is created. So there's 3 different types of states, and those are session states, application states, and persistent states. So when a state starts and ends is dependent on which type of state that it is. State management is the process of maintaining web page information about a web page. So what are the different states? Okay, so a session state is created when access to an application is requested by logging in. Okay, and it ends when a user ends the session or logs out of the app. Okay, so that's a session state. An application state is created when a browser sends a request for a web page to a web server. It ends when the browser is closed. Okay, so you can see the application state then is related to the browser status, and the session state is more related to the user, the user's status with that, whether they're sort of still in the session or whether they've logged out. Persistent state information is data that remains for use by an application after a session ends. Okay, so this allows an app to continue its state when a user returns to a site, which can be obviously very useful for a certain number of applications. Let's have a look at cookies. In order to work around the fact that HTTP is a stateless protocol and therefore doesn't retain data from one session to the next, developers can use cookies. So cookies are small files that save information about users and are saved on the user's computer. The browser will send cookies back to the web servers, and then the servers use these cookies to identify a user and then customize their experience. So you can see the cookie as a sort of ID card, which is used to identify the user on the server. Okay, so a significant amount of information or data about the user could be held on servers. Cookies are very useful, however there are some limitations and a number of problems. So the first of these is the security risk. So a cookie is sent and stored in clear text and not encrypted. Therefore there are potential security issues related with that. Also, the performance can decrease due to the amount of data that is being sent backwards and forwards between computers. And also the cookie is limited in size to 4 kilobytes and is not a program, it's only a text. Okay, so there's a limited amount of information that can be kept using cookies. that is a limited amount of information that can be kept on the user's local machine. So HTML5 has brought in the web storage API, which consists of two particular types of web storage. One is called local storage and another is called session storage. Now, we're going to be having a look at both of these. Okay, let's have a look at local storage and session storage. The main difference between the two is that local storage lets users save larger amounts of persistent data. Now, this data is held on the local machine, and there's no limit to how long that data is kept for. Now, session storage lets users save session data. This session storage data is only valid and only lasts for the duration of that one particular session. So if you have a tab open in Internet Explorer or Chrome or any browser, that session storage is only valid for that one particular tab. Okay, so you could even have two different versions of the same web page open in two different tabs, and each of those two tabs would be using a different session storage, i.e. a different instance of session storage. Okay, the data would not be shared from one tab between one tab and the other. So anyway, but both methods allow users to store large amounts of data without slowing down the connection, because the data is transferred only when. Okay, let's have a look at app cache. Okay, now data can be stored locally when a user is offline using application cache or app cache. It's worth noting that this does appear in the MTA PDF, but is not now implemented. Okay, so app cache has been deprecated, but as it is mentioned in the book, we're just including it here, just on the off chance that it might come up in the exam. Okay, so app cache stores resources such as HTML, CSS and JavaScript files locally on the user machine. So obviously that enables or would enable the users to access those pages offline. The developers can dictate which type of information is stored locally in a cache manifest file. Okay, it's different from the app manifest file. So it's a cache manifest file, particularly relating to that web page for which you're keeping some files. Then from Mozilla, HTML5 provides an application caching mechanism that lets web-based applications run offline. Developers can use the application cache interface to specify resources that the browser should cache and make available to offline users. Applications that are cached load and work correctly even if users click the refresh button when they're offline. Okay, and there's that link there where you can look at that in a bit more detail. Let's look at debugging and testing an app. Debugging and testing are very important steps in developing high-quality web applications. They ensure apps run reliably and error-free. Debugging is the process of detecting, finding and correcting errors in logic and in syntax. Logic errors prevent the app from behaving as expected, whereas syntax errors are typos in the code which prevent web apps from running. Next up, validating an app. How can you validate HTML5 code? Well, you can use a validator to test code for inaccuracies and syntax errors. W3C provides a code validation service for all versions of HTML and CSS, and you can access this from validator.w3.org. The purpose of a validator is to ensure that the code is properly interpreted by browsers. testing and debugging. Your goal is to provide a reliable, secure and useful app to customers. Debugging and testing are a vital ingredient to ensure that all these three objectives are met. High quality apps get high quality ratings, which can therefore boost your profits and drive sales of future apps. So it's very important to get this right. If you plan to publish your app through the Windows Store or another reputable online app marketplace, the store will require validation or certification that your app has been tested. Developing for touch interfaces. Before we develop touch-enabled apps, we have to understand how fingers interact with touchscreen devices. Finger moves are called gestures and can include a press, tap, slide, and other gestures. How an application responds to a gesture is called a touch event. We can use JavaScript, including the touch start, touch end, and touch move methods to create touch events. Packaging apps. The packaging of an app is the process of bundling an application's file to enable distribution and installation on different devices or systems. If you want to package and publish an app in the Windows Store, you can use the Windows App Certification Kit to test it. The Windows App Certification Kit provides a report describing any problems with the app. If there are problems, then you should correct them and then test your app again until it works. Publishing an app to a store. After you test, debug and validate your code, it will be ready for upload to a marketplace for apps. If the app was built for Windows, then the marketplace will be the Windows Store. There's a 5-step process that you should go through before you publish your app to the Windows Store. First off, sign up and pay for a developer account. Once you've done that, go through the app submission checklist. You can capture screenshots of unique features in your app. These will later be used to help advertise and promote your product on the Windows Store. Fourth, make sure other users test your app on multiple devices and platforms. It's always beneficial to get other people who have not been involved in the build process to test your apps. Lastly, include a privacy statement if your app gathers personal information or copyrighted software.